If we're trying to understand the warmth of something, there's kind of two things that we need to know. We need to know how much down quantity, how much down is in any given area over you. And then measured loft, which is how much loft space is that amount allowed to occupy. You know, does it loft up really high? Is it held really dense and short? In this video, we're going to be focusing on ways to obtain useful down quantity metrics. The specs that we are provided with are total fill weight and fill power. Total fill weight being the total amount of down in weight in the entire item. Fill power being the fill power rating of that down, which is, how much volume does 1 ounce of that down fill. And we can take those two things and multiply them together to get total down volume in the whole thing. But that's not really very useful to us in terms of assessing warmth, because that total down volume is spread over the entire area of the quilt. And unfortunately, different quilts, even if you're really careful to match up specifications, even if you get the same dimensions as advertised, there's really dramatic differences in total area between different quilts. And obviously, the 13.7 ounces of total fill weight spread over 4,000 square inches means something completely different than that amount spread over 5,000 square inches. And those are margins that exist on the market everywhere. So in order for us to assess warmth using these specs, we need to know how much area this quilt has. And this video is going to be about how I'm taking these dimensions so that you can repeat them at home. Alright, I would say the first step in taking measurements of a quilt is to determine whether or not the quilt has a differential cut or not. So over here on this one, if we apply tension to the top of the quilt here, we can see that the inner shell is taking all of the load and the outer shell is still loose and allowing the down to remain lofted up. So that is a differential cut. You can see we can pull the quilt and the load is taken up by one shell, but there's still loft here. So this has a differential cut. Now over here, you see we do the same thing, and both shells take the load. Both shells are cut to the same dimensions. When you put tension on them, both of them flatten out. We can move it down further here. We can see tension there. We can do it this way. If you pull, you can see we have tension on the outer shell, tension on the inner shell. So no differential cut here. These shells are cut to the same size. The reason that's the first step here is because we want to take the dimensions of the smaller shell. We're looking for the footprint or the area of the quilt, not the shell that's meant to sit loosely and allow the down to loft. We want to know what the area is. So we're going to proceed on this one as if it did have a differential cut, just for an example. But if this did have a differential cut, we would take the dimensions out of the inner shell, because that would be the smaller shell typically. Okay, we have our measurements of that quilt, and we can take those measurements and find the area of each of those thirds of the quilt, or if it happened to be quarters or halves, you can do it that way as well, then sum them together. So here we have the top section, the middle taper, the bottom footbox section, and the footbox round end all summed together to get 4,006.3 square inches in total for this quilt. So now we have all of the information we need to distill our down quantity into a useful transferable metric. So we can take our total fill weight, 13.7 ounces advertised in this quilt. We can take our fill power of 950, which means that 1 ounce of that down fills 950 cubic inches. Now if we multiply those together and get the total down volume of 13,015 cubic inches of total down in this whole quilt. Now, if we take, now that we know our area and we know the volume of the down in the whole thing, we can divide the total down volume by the square inches of the quilt, and we bring that down to 3.25 calculated loft, which means that in every square inch of this quilt there is 3.25 cubic inches of down. Also means that if you took a snapshot of 1 square inch of this quilt and you opened the top of the chamber such that there was no density, that down would loft to 3.25 inches, hence calculated loft. And now we can, that number is completely objective. That just means that there is 3.25 cubic inches of down in every part of this quilt, and you can take that number and you can compare it to something that is a completely different size and compare it to its calculated loft number. You could take this quilt and you could compare it to a quilt of an entirely different size. You could take it and compare it to a mummy bag. You could take it and compare it to a jacket. Literally, this is an objective number that means 3.25 cubic inches of down, and it's transferable. It's not a full picture of warmth, but it is a full picture, and it is an objective picture of down quantity. Occasionally somebody will ask, well, you say that there's 3.25 cubic inches of down in every part of this quilt, but how do you know that this chamber is filled to the same level as this chamber here? The answer to that is really that's kind of just how it works typically. In most cases, the manufacturer is literally using this number to fill the quilt with. We are sold down from the processor with a fill power rating for the sole purpose of us being able to quantify the volume that we put into products. We purchase filling machines that measure weight for the sole purpose of taking that fill power rating, measuring the weight, and being able to quantify volume with it. So yeah, in most cases we're literally using that number to fill each of these chambers and ensure that each of them are consistently filled. The front end of that looks like, the builder, manufacturer, engineer is going to play around with different chamber volumes versus down volumes and get the right ratio that they want, and then lock those numbers in so that it's repeatable for the next chamber, for the next system, every size of the system. In this one in particular, we've got a 5-inch wide chamber with a 2-inch tall baffle, and then they have 3.25 calculated loft in that space. So, when you take this volume of down and you put it into this volume of a chamber, you get, a chamber profile that looks like that with a, 2-inch tall sides and a certain amount of shell puff. So it's really a process of inefficiency that most of the time the manufacturer already has this number. They're using it for the manufacturing process. And, we actually have to go through extra labor in order to measure the weight of each chamber and tally all of that up so that we can provide total fill weight to the consumer, which is actually, the consumer is finding that they can't really do anything with that number. It doesn't really give them an accurate view of anything. And so that, now they have to go through the labor of then converting it back to a useful number that we already had. It's unfortunate, but that's where we're at. Anyway, in the case of a builder that does not use volume to fill, typically that process looks like this. That builder, instead of calculating the volume and ensuring that consistency, what they would be doing is they would build out a prototype for every size that they're going to offer, and then the experienced builder that's going to use eyeball and intuition and feel to try to get consistent fill throughout the product that they're offering. They're going to build out those prototypes and record the fill weight that goes into each chamber, and then they'll lock that in so that it's repeatable down the line by themselves or another builder. But also in that case, that by feel builder is aiming for consistency. They want to have this chamber filled to the same level as this chamber, because if this is a 20-degree system, they need to make sure that these are filled to the same level. So ideally, if they're doing their job well, they're ending up with the same level of consistency that the volume calculations are ensuring. So in that case, the calculated loft to per area down volume still applies.